Welcome to the Road to Zero podcast. I'm your host, Nick LeBlanc, founder of Network Potential Consulting. We're here to explore the fast emerging zero impact economy, which is transforming the way we do business, bringing prosperity and regenerating the natural world in the process. And I invite you to look at how you can position your business at the forefront of this global movement. Today on the Road to Zero, we're talking to Sophia Hamblin Wang, Chief Operating Officer of Mineral Carbonation International. And she's joining us from Canberra, Australia. Welcome, Sophia.
Thank you very much for having me, Nicholas.
It's a pleasure. And I'd like to hear, how did you get involved in the carbon sequestration business?
I was at university in Australia doing a PhD when I decided to take a year's leave. And at the time, the founders of MCI, Mineral Carbonation International, had secured a $9 million loan grant from the government and industry. And so my PhD topic was corporate social responsibility and designing business models that have a high social impact and a high return on investment. So I decided to take a year's leave and help them to start the company, to set up all of the systems and learn a little bit more about the academic literature in practice that I was actually studying at uni. And a year came and went, and I just absolutely loved it. And that was in 2013, and here I am 8 years later, still going strong.
Yeah, I hear it's been this is not an overnight success by any means. There was a big period of research and development funding by the government, and I think 2020 is when the commercialization process started. So can you give us an idea of where you guys are at right now?
So maybe I can frame the technology a little bit first so that people understand. When we first attracted the $9 million worth of funding in 2013, the mineral carbonation technology had been proven at lab scale. And so that's converting CO2 into minerals or reacting minerals with carbon dioxide, turning a gas into a solid. So it had been proven at lab scale, and the IPCC had actually called for a global reference pilot plant for mineral carbonation, but the world had not yet, didn't have one yet. So the initial funding that we attracted was to scale up lab scale mineral carbonation technology into a pilot plant. Now, the whole focus of our project originally was to investigate how the technology could be complementary or different to carbon capture and storage. So it was always focusing on what is the cost of storage of carbon capture and use versus carbon capture and storage. But over time, we came to discover and finesse our business model so much that now we're able to make profitable products from carbon dioxide. So it's not just about the cost, it's about how much value can you create out of a ton of CO2. And that's been a really significant breakthrough.
Yeah, and I know a lot of technology up there, they'll usually give you the economics of how the carbon credits makes it financially viable. But my understanding is you've actually found a methodology where you don't even need the extra funding. You've actually found a way to actually create marketable products, and the economics are actually don't need any government support.
That's right. We don't need a carbon price to be profitable at our scale up, but that's been something that we've had to design over time. So in 2013, when we got our first funding, the Australian government actually had an emissions trading scheme at the time. So many large companies that had emissions that they anticipated they would need to have future liability on their balance sheet started to invest in technologies and innovations that might help in the future. And so we were one of those companies that were able to attract funding and support. But unfortunately, shortly after that, the emissions trading scheme was repealed. And what we've seen is a real slowdown with regard to global momentum for climate action and carbon abatement or carbon utilization. So there were about 4 or 5 years in the middle there that it was really, we needed to develop a technology where we were showing companies that, hey, your emissions are a resource. Your carbon dioxide can be turned into a profit. And we knew that that's the quickest way to get companies to act. Waiting for governments to legislate and to markets to emerge, it's really encouraging that that's happening now. But over the past 8 years, we've had to bolster our business model in order to ensure that profit or that there's more than one way, more than one benefit to what we do. This is quite significant because we're really focusing right now on the transition. We know quite well how the energy industry is going to decarbonize over time, and the transition is important, but renewables and hydrogen look very positive, and we know we've got a clear path to decarbonization over time in certain industries. However, the steel and cement industry, chemicals, mining, they all have a much harder time in envisioning how they're going to get to net zero. And we also know that even with best case scenario, the likelihood is that we will need negative emissions in the future. So we'll be needing to suck CO2 out of the atmosphere. What Mineral Carbonation International is doing is we're looking at this whole ecosystem and looking at our entire economy, not just energy, and saying if a steel plant and a chemical plant, they had retrofitted carbon dioxide capture onto their plant, what would we do with that CO2? Currently, there aren't enough endpoint markets or uses or storage options for the CO2 that is produced in industry. And even if over time we start to replace certain industries with new, greener options, we still have 20 or 30 years of life for many of these industries where they will need to run until the end of their life. So the transition emissions are going to be phenomenally important, especially in this when we envision what our life is going to be like in 2050.
Yeah, you made a really interesting point about the importance of that government funding, that incubation of the industry, and how fickle it's been. Because your experience hasn't been the only one. I know even here in Canada, we've had that where the government had a program and then the government changed, it took the program away. And you can really see the impact it has in companies like yours when you're actually trying to revolutionize and bring value to the economy. And what I'd like to hear a bit more is how a little bit about how the technology, how do you go about taking this gas and turning it into something useful, and what are the things that it gets turned into?
So we class ourselves as carbon agnostic in that we can take CO2 from any industrial source or direct air capture, any place that has a CO2 source that's basically above 15%. So we can also take raw flue gas, which is quite a significant breakthrough in what we do. We take those emissions and then we react them with minerals in our pilot plant in Newcastle. So the minerals that we use are typically magnesium-rich serpentinites or olivines, but also calcium-rich minerals. But also we can react the CO2 with industrial wastes like steel slag, incinerator bottom ash. Mine tailings are also a very interesting use case. So the variety of feedstocks that we can use is quite broad. So in the serpentinite case, what we would do is we would take the serpentinite ore and we would pass it through our reactor and bubble CO2 through it. And through our breakthroughs and through our scientific and technical process, we've been able to optimize the reaction of the absorption of the CO2 into the mineral. And that creates magnesium carbonate and silica. And those two outputs we then process into low emissions or negative emissions materials. The use case that I always talk about when I speak on at big conferences is usually I'll show people our cementitious products. So our cementitious products, and we also have a plasterboard gypsum replacement material that is actually a negative emissions material. So this is a neat way to illustrate, this plasterboard replacement is rich in CO2 from an ammonium nitrate factory. So it's taken directly from industry, passed through our reactor, and then a negative emissions building product has emerged. Similarly, this cement brick is a byproduct of our other output, silica, and so 10 or 20% of ordinary Portland cement can be replaced with our product, which indicates a 10 or 20% reduction in emissions potential for the product itself. And then, of course, you would have heard with your other interviewees that we also have this displacement of so with this cement brick, 20% of the ordinary Portland cement in it didn't need to be made, and so we're displacing highly emissions intensive original materials that had to be mined with our synthetic carbonates and silica. Is that clear?
Yeah, really clear. So what I hear, it's not just one product. You've really got a variety of things that can be done with the process. And it's interesting how you're actually even taking waste products from other processes and the CO2 to actually create these actually quite valuable new products.
That's right. And I feel sorry for the people on the podcast because I'm actually showing the things and they are quite a neat way of people to see and touch and feel what climate action can look like, that you can turn emissions into solid and valuable and useful materials for the built environment. But you're right. The point is that we designed our platform in order to lock away the maximum amount of CO2 possible. And then we produce these negative emissions or low emissions materials. And right now we're just in product development with all kinds of companies from all over the world to look at what could we possibly create out of emissions, out of these materials. So it's not just building materials, obviously, it's, home care products. So the problem is that I can't say because I'm under NDA with a lot of these companies, but it's basically everything that you can touch when you wake up to when you go to bed to everything from the walls to the ceiling to the floors to when you read a book, so many things. So the future looks quite bright when you consider you can use our carbonates in so many different products, and it really helps to paint a picture for what the transition could look like for emissions instead of just emitting them into the atmosphere and treating our atmosphere like a sewer. We can be taking that waste and reprocessing it, and it's all part of the circular economy.
Yeah, that's a really valuable point. That's such a great way to bring that stream. And what I love is that those follow-on impacts, where by doing that, all of a sudden you've displaced the carbon intensity of this product and that product. So that has a lot of follow-on effect. And tell us a bit of an idea of where I hear there's definitely like you've got this demonstration plant, you're looking at what else you can do. So just give us an idea of what you've got on the ground now, and we'll talk a little bit more about where you're going next.
So I'm thrilled to be able to tell you that last night, our federal government in Australia just announced that they are going to give us a $14.6 million grant to build a demonstration plant. I'm so thrilled for this because it's a significant breakthrough in support and indication that our technology has momentum. We've known in our hearts and with our partners and our customers that our technology works, but getting the government's support in such a phenomenal way is going to really accelerate our technology. Right now in Newcastle, we have a pilot plant, and we understand it's one of the first of its kind and one of the biggest in the world. And so right now we're taking CO2 from an industrial source and we're producing these materials every day. But we need to scale up in order to be able to meet our climate goals. And we have quite lofty ambitions in that we want to reach 1 billion tons of CO2 locked away in the future. So that's quite exciting. The interesting thing about mineral carbonation and about the particular process that we use is that the feedstocks that we focus on are so naturally abundant, and they don't compete with farming land and all that kind of stuff. They are so abundant that there is technically enough of these feedstocks in the world to lock away all of the CO2 that has ever or will ever be emitted by fossil fuels. So we're not limited by that fact. That basically the biggest thing that's holding us back is policy, access to funding, and just momentum.
No, what's really exciting is how limitless it is. And what I hear, you're not stuck to geography. You don't depend on a special kind of geography. Sounds like you could have one of these plants pretty much anywhere, and those feedstocks would be anywhere. So it's very universal technology. And just give us an idea what the plant you have now. What's the yearly throughput in carbon sequestration? Just to give us an idea where it is now with that small demonstration plant.
At the moment, we're processing several hundred kilos of CO2 per annum, and that provides a really good techno-economic feasibility assessment in order to scale up to the largest plant possible in our next scale up. It's just to touch on a point that you made just before. There is an abundance of feedstocks, particularly industrial wastes, but the serpentinites that we also focus on, there is an abundance of them in the world. However, they aren't everywhere, but they are in a lot of places. And part of our full focus has been on mapping and identifying the ideal places that we would source the feedstocks from. And then also, so we have the holy trinity of the things that we need in order to be successful. We need access to feedstocks or industrial wastes. We need the CO2. So that's, I think, going to become less and less of an issue in the future as more and more technologies both capture and pipeline their CO2. And then finally, we need product markets. We need places to sell the products in order to make a profit and in order to be a part of the circular economy. However, in the long-term future, when we do have a negative emissions scenario, we foresee a time that we could be building a plant anywhere in the world and next to a direct air capture plant, and just suck CO2 out of the air and lock it straight back into the earth, and just either claim carbon arbitrage for the highest price or whatever mechanism emerges. I'd be very interested to hear your thoughts on that, because I know that you've had some deep dive conversations into this very topic.
Yeah, no, that's a really interesting one. And you made a really good point, because right now we're in this like race to survive, to try to reach some kind of equilibrium where we're not increasing that level. But you're right. At one point we'll figure that out. Is that we've kind of raised the ceiling quite a bit from where it used to be, right? So we're going to have a hotter planet for some time. And that whole piece of regeneration, where companies are looking at how do we turn the thermostat down to bring it back to past equilibrium. You make the good point about how this technology would be perfect for that. And you're seeing a lot of that scaling up now, where we're not just offsetting emissions from a plant so they could keep doing what they're doing and not have a negative impact. But there are those that are just actually decreasing what's there. Like if you look at the whole concept of Project Drawdown, how do we do that? So you really identified, and it's interesting, even your business plan, you have identified that there's a market to bring people to neutrality, and that's going to go away in a certain number of time. So I'm really happy to hear that you're actually looking, then what do we do after that? And there's a whole business model on how that works. So it'll be interesting. And I haven't heard how the world's going to sort that out. Who's going to pay for the remediation piece? So it'll be interesting. And if your technology is at the point where it's actually economically viable, where you can just create these new products out of the CO2 in the air cheaper than someone else, you've kind of got it figured out from the sounds of it.
I hope so. You know that the G20 last year signed a circular carbon economy pledge, and it was that we should reduce, reuse, recycle, and remove carbon dioxide, which was quite a big deal for us in the CCU sector. And I think that also the Elon Musk X Prize has additionally helped people to understand what negative emissions, direct air capture, and carbon capture actually is. And I think that ideally we won't need direct air capture, right? Ideally, we can capture all of the industrial emissions and stop emitting as quickly as possible, and we won't need it. But I live in Australia. We had some of the worst bushfires in living memory last year. We are living through our lived experience is starting to show extreme weather events are going to become more and more prevalent and more extreme. So I think we do need to come up with as many solutions as possible, and because different solutions will work in different areas, and there's no silver bullet for climate change. It's going to take a portfolio of solutions. And that's why I think it's really important for us to all be collaborating and having these conversations and sharing insights, learning from failure. All of these things are phenomenally important. I might just add there that last year in January 2020, I was in Davos at the World Economic Forum, and it was a massive, it was a huge deal for me to be invited to go and speak on a panel about building a new carbon economy. And so actually seeing the value that carbon dioxide can bring to our lives if we look at the circular economy and we look at, you know, the full life cycle of carbon from cradle to cradle. And that was just a really great thing for the technology, for MCI, and for me personally. But at the time, Australia was literally burning, and our government was there, and we had been, I would say, laggards when it came to climate action. And so it was a little bit embarrassing for me because I was feeling like that was our moment in time to stand up and announce additional measures to get to net zero and to help the rest of the world to get to net zero. Because when you really look at what Australia is built on, a lot of the carbon dioxide in the atmosphere was dug out of Australian soil in the form of our coal, and we are really grateful to the minerals sector and to coal and to everything in order to build our society, to bring us up, to build our GDP, to make us prosperous. We're really grateful for all of those things. And now it's time to acknowledge that and transition into industries of the future that don't cause the harm that we now know that carbon dioxide causes.
Yeah, and that's a very key point, especially the industrialized countries of the world that we benefit from it. I guess drawing into that carbon bank account, if you will. And I think and there's definitely a moral imperative there, but I think most importantly, even what you've demonstrated, there is an amazing economic opportunity by diving headlong in this transition. Like just what you said, creating products that are even cheaper, using this waste that we have to pay to get rid of. And we're like that whole concept of the circular economy, it's really changing things dramatically. And from an economic perspective, like there's a huge business opportunity in there.
In the past few years, Carbon 180 and the Global CO2 Initiative have estimated the market size for carbon capture and utilization. So a few years ago, it was estimated at around $1 trillion, and now it's come up to be around $5.9 trillion globally. But it looks like these figures need to be updated because I've got a strong inkling that it's in fact a lot larger than that. So there is a really significant economic incentive to be a part of this emerging industry. And in fact, Christiana Figueres, in a conference I was at last year in COVID, so online, but she said that the most significant thing that we can see right now is that there is a race to zero emissions with the competition in the world. The largest the largest companies, the biggest leaders in the world, have staked their claim either net zero or negative emissions. If you look at Microsoft's case, what they've done is they've said, "Hey, we're going to do this before anyone else," and now there's this crazy race to purchase all of the good quality, low hanging fruit carbon offsets. So in the future, as soon as the rest of the world catches up, and it's happening every day, we're going to be needing to create high quality, permanent carbon offsets that are actually going to help the world get to net zero. And I think what we haven't quite grappled with yet is the fact that we don't have enough of them right now. So as soon as the competition buys them and then is able to make that claim, it's going to alter markets. And so this is something that I need to constantly be updating myself with the news, the literature, and speaking to brighter minds around me about how to anticipate where the market's going to go. But we know that we can make money out of our products, but we also know that generally when it comes to carbon utilization products, we need to be able to create products that are comparable strength and everything, but it needs to be cheaper. It needs to be better and cheaper in order to get the market to adopt it. And that's something we've known all along, and that's how we've been building our products with that in mind. And it looks like it's going to work out, but it's also something that I'm happy to speak to people about.
And then just a quick question, just to get a better idea what the future looks for you. So you've got this massive investment and you're building a scaled up plant. What do you see as the timeline to that, of when that would be in operation and when you're actually able to make that jump?
So the funding that we've just received that has been announced from the federal government, the project will start this month, and we will have built our demonstration plant in 2 years' time. So it's quite a fast track, but that is by no means the only thing that we're doing. We're likely to be building multiple demonstrators all around the world. We're likely to be scaling up in an accelerated fashion. So that's the thing on our immediate plate, but it's by no means the only thing. Additionally, we have customers all around the world from some of the largest companies in the world, where we're looking at helping them get to their net zero. And the exciting thing is that there are all kinds of focuses that are emerging that provide significant opportunities for new markets. And so we're signing offtake agreements. We've got upstream and downstream carbon value chain customers, and bringing all of those parties together has been one of the really interesting things, because you may have a customer that has a lot of CO2 and they don't know what to do with it. And then you might have a customer who would really like to have a lot of low carbon inputs into their products, but those companies may never speak to each other. And so we've been brokering quite a lot of really elegant partnerships. And I look forward to being able to tell you about them.
Yeah, so it sounds like you're building this thing, and by the time it's built, you'll already have lined up your inflows of supply and even your customers. So it sounds like you're hitting the ground pretty fast. So, and I would say in 2 to 3 years' time, we'll see a radically different market out there and some pretty amazing things happening.
We will also be doing a significant capital raise at the beginning of 2022. So this is an opportunity for us to get really big investors from sources that have key insights into carbon markets. So we think that the beginning of next year, after COP, after the dust settles and we know where global governments are going to go, that's the right time for us to do a significant capital raise, which is going to really shore up our growth strategy into the future. So I thought it's probably worth mentioning that to you.
So yes, I hear there's definitely opportunities out there for people that want to maybe get your products, get involved, create some partnerships, and I hear investment opportunities as well.
That's right.
Yeah. Anything else you'd like to put out there that you'd like to see?
I think that the really important thing for the world to know is that there are going to be many technologies that will help us get to net zero. And the circular carbon economy and carbon capture and utilization is going to be a really key part of us getting there. Unfortunately, in the past, CCU has had to compete with other technologies groups for funding. And I think that if I want anyone to leave this podcast with, it's that carbon capture and utilization is a whole business model and a value proposition for CO2. And if we can educate our policymakers and financial backers and funders about that, I think that that's really going to incentivize the bright minds of tomorrow. We're going to incentivize the bright minds of tomorrow to invest their time and their careers into this field. I've had a really wonderful career building this technology because with by the way, an incredible team of people. We have 20 people at the moment working in Australia and around the world on our technology, and we're obviously all very committed to the outcome of storing and utilizing as much CO2 as possible. I want to tell people that this industry is really exciting, it's emerging, it's worth investing your time and your career into.
Well, thank you very much for being our guest and just introducing us to this world that we're about to see.
Thank you very much for having me. It's been a pleasure.
It has. Enjoy the rest of your evening, I guess your evening or your day out there in Australia.
Thank you.
Thank you for joining us today. Check us out at www.futureproof-network.com to hear our other episodes, links to our YouTube channel, and to join our Future Proof Business Network. See you again on our next episode.